Alright, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? Home plate? Yeah? Okay, good. So today's warm-up number 62 is on the screen. Number 1, it says simplify and round your answer to the nearest tenth. They give you square root of 75. Number 2 is graph f of x equals x squared without a table. Then write the rule of the graph of the transformation is g of x equals af of x. 1 over bx minus h plus k. Given the parameters a equals -1, b equals 1, h equals -2, and k equals 3. Number 3, factor completely. Part A is x squared minus 6x plus 8. Part B, 4x squared plus 8x plus 3. Number 4, divide the polynomial with synthetic division. They give us 3x cubed plus 22x squared plus 37x plus 10 divided by x plus 5. And number 5, write and graph the equation of a circle. X squared plus y squared minus 10x plus 6y plus 30 equals 0. Copy that, and I'll give you some time for that. And go. Alright. So you should be just about done with the warm-up. Now, FYI BTW, and this is being recorded. I'm going to put this in the lesson for the YouTube video. As I was saying yesterday, since there's plenty of people that I have been absent for whatever the reason, I'm going to be going live on Zoom every day at 1:30. I'm going to be going live on Zoom every day at 1:30. How do you get there? You go to Canvas. In Canvas, there's a button that says Mr. Q's Zoom. It's in red. Click on that, and I'm going to be live at 1:30. I'm going to be live at what time? 1:30. Yeah, so basically during 6th period. So just click there if you're absent, and just wait for me to accept you into the session. And just be aware I might be asking you questions, and you're going to be interacting in class like if you were here, but you're going to be at home, of course, having some hot Cheetos or whatever it is you do. So make sure if you have anyone that you know that are part of my class that I have been absent or are going to be absent, let them know that to go to Canvas, click on Zoom, and be there at 1:30. All right, here we go. Number 1, simplify and round your answer to the nearest tenth. So this was approximately, Lewis, what'd you get? 8 point something, yes. Hands, have you got 8 point something? Yes, that something is 6. Hands, have you got that? All right. Oh, so let it go. Let it go. All right. For number 2, for right now, I'm going to skip number 2 since you guys are experts at that one already. I'm going to go to 3. Factor completely. Lewis, pass someone. Philip, what'd you get for number 3A?
I got x minus 2 and x minus 4.
X minus 2 and x minus 4. They're both multiplying. Hands, have you got that? That is correct. How do you get there? 8, -6. Two numbers that multiply give us +8. But when you add them, give us -6. That was -2 and -4. And there you go. Pass someone? Raymond, 3B. What'd you get? All right. Let me help him out. What number goes on top? Not the 3. Now that we have a leading coefficient, we multiply 4 times 3, therefore it's 12. Then the middle term is 8. What two numbers multiply to give me 12 that when you add them give us 8? 6 and 2. 6 times 2 is 12. 6 plus 2 is 8. Then what do we do from there? We rewrite this, and then you group and factor, but for the sake of time, I'm going to use a shortcut. You guys remember I showed you the shortcut first semester? Okay, good. Here goes a shortcut for these that forgot. I take the leading coefficient and write these two using that number as fractions. So you're like, what? Yeah. Take this fraction, simplify to lowest terms. What is the simplified fraction for that one? 2 over 3, is that correct? Which means my first factor is 2x plus 3. do that for this one. What's the simplified fraction of 4 over 2? 2 over 1, yes? So my factor is what? 2x plus 1. You're like, what? You guys remember the shortcut, yeah? I mentioned it. I said this is the Escalante method from the movie Stand and Deliver. You guys remember the... No? You never mind. So, all right. Number 4. For the sake of time, once again, I'm not going to go to the entire process, but my divisor, we start with -5, right? Because you need it to set it equal to 0 and solve. My coefficients and constants are 3, 22, 37, and 10. Bring down the 3, and we begin. What is -5 times 3? That's -15. Combine, that's 7. -5 times 7, that's -35. Combine, that's 2. -5 times 2 is -10. Combine, that is 0. If we started with a 3x cubed, that means this one's no longer 3x cubed. This is 3x squared plus 7x plus 2, and we're done. And number 5. Number 5 is the challenging one because it requires a lot of process, and the process that we practiced before Christmas break was completing the square. I don't know if you guys remember, yeah? So subtract 30. I'm going to combine like variables. So I have x squared minus 10x, leave an empty space, plus I'm going to combine y squared with a 6y, y squared with a 6y, leave an empty space. Now that equals to -30. How do we complete the square here? Well, we take this number, the coefficient of x, divided by 2, squared. You add that to that. That means we do to the other side. How about here? 6 over 2 squared, 6 over 2 squared. All right, let's simplify that. X squared minus 10x, and this is 25. -10 divided by 2 is -5. -5 squared is 25. Plus y squared plus 6y plus 9 equals -30 plus 25 plus 9. Let me combine the right side and then factor the left. What is 9 plus 25? 34 minus 30? 4. Then you factor this one. Square root of the first. X. Square root of the last. 5. Sign of the middle. Negative. Plus. Square root of the first. Square root of the last. Sign of the middle. Squared. And that's your equation for the circle. But they want us to graph, which means we need a what? A center. What's my center? 5, -3. What else do I need? The radius. What's my radius? Close. 2. Remember, we need to take that number and take the square root of that one. All right, so if I was to graph that, let's see. -3, 5 is over here, -3 is about right there, so my center is right there. The radius is 2 steps in each direction, 2 steps this way, 2 steps this way, 2 steps this way, 2 steps this way, and there you go. Woo, let's go. Some of us say this is too easy. Right? Am I right? Am I right? Yes, Mr. Q. You guys all right? Yeah, you guys need some coffee or something? Yeah? Yeah? There's this place in San Diego that sells really good coffee. It's called Trader Joe's. Trader Joe's. They have good coffee there.
Don't get them to drink to the coffee already.
What's that?
Don't get them to drink to the coffee already.
Okay, then they have very good waters there.
Oh, wow.
Agenda for today, warm-up number 62, Parabolas, and tonight you only have 8 problems to do, only. I hope you enjoyed last night. Last night they were only 6, yeah?
Yep.
Okay, good. Once again, warm-up number 62, parabolas, and 8 parabolas to graph for home plate. All right. Asynchronous code, for those of you that want to follow along using Nearpod, ANIQK. ANIQK. All right. Previous home plate, last night you needed to do 4 from page 183. It was in Canvas and also in your electronic text, if you had your electronic text. Or these 2 extra ones that also I gave you, so it was a total of 6. So for the sake of time, I want to get to the lesson. You can upload that on Canvas on your own. I'm going to give you guys the window. It's open till 4 o'clock, so do that later on. Okay? However, at this point, this is the home plate for tonight. Get your phone out, take a picture, please. So like that, there's no excuse. Oh, Mr. Q, I couldn't find it. There you go. You're like, I can't find my phone. Oh. It's only 8 problems, only. Right? Yeah, it sounds like very little, yeah. And reminder, those of you that, if you see that today's lesson is challenging, tutoring after school, it's free. Be there or be elsewhere, yes? Alright? So, everybody took a picture of that, yes? Alright. Those of you joining us online, make sure you pause the video so you can copy those and get started with those if you at the end of the video. So, our objective for today, I can write and graph a quadratic equation of a parabola. Get a Cornell note ready. Don't need a Ferrer model, but you do need to take notes. And also, could I get, let's see, the first person on each row, go get a graph paper for your row. They're over there on top of the cart, and I'll give you guys time to set that up. All right, here we go. So, in regards to yesterday's practice, hopefully you did practice that on your own. You're going to need that for today. Yesterday's rigor, if I was to scale it from numbers 1 all the way to 10, I would give it in rigor of 5. You know, it was all right, you know. Today's rigor is going to be at about 8. So I'm just giving you a heads up, okay? Because it requires a couple components that we need to go back and forth from graph to algebra and computation, okay? All right, here we go. So, once again, I can write and graph a quadratic equation of parabola. Our concept for today's parabola, we don't need a Ferrer model since we already have it. So, yesterday you filled one of these, yes? Yes, Mr. Q? All right, good. From there, I showed you the standard form equation of a parabola that looks like that. From there, I showed you the process that you needed to do on your own over the vacation that you memorized, which is all this, yes? Okay, good. And then from there, we got to this point where you saw the vertical parabola, horizontal parabola, yes? And we said we were going to use these 2 equations throughout, yes, Mr. Q. I used those in my home plate. Then I gave you guys a couple of problems to practice. So, just to get our noodle ready, look up to the screen, don't copy this. Here it goes. Let's see how well you practiced last night. If I was to give you this one again, what is the first thing we look at? At the Directrix. If we look at the Directrix, now we know which equation to use. Turn to your neighbor, let them know the equation that we would use for this one. Yeah, x squared equals 4py. Okay, let me move on. Look at this one. Once again, you're not copying this. It's just like extra noodle practice. Here you go. Look at the Directrix. Tell me never the equation that we're going to use for this one. Yeah, y squared equals 4px. So far so good, yes? Alright. What else did you notice from yesterday's home play? That all the parabolas went through the point of origin. Is that correct? All of them went through the point of origin, which means that the vertex was at the point of origin. There and there. It didn't matter if it was up or down or side to side. They all went through the point of origin. What does that mean, Mr. Q? That means, once again, that these two yesterday had a vertex of what? 0, 0. Is that correct? Now, why are you telling us this, Mr. Q? Because today we're going to add transformations to the parabola. You're like, yes. Which means today, if you notice yesterday it didn't move. The parabola stayed on the vertex at 0, 0. So think about this. If it didn't move yesterday and we're moving it today, that means we're going to move it either side to side or up and down. Tell your neighbor, what parameters are we going to include now in our equation? Yes? Very good, yes. Today we're going to include what? H and? That is correct. So copy these two new equations and our new vertex. Yay! I'll give you some time for that. Copy and go. Alright. So, what do you guys notice different from the original to these? That now we include H and K. But notice where each parameter goes. The H will always remain with the X, because that's part of the general rule. Remember when we did transformations? It was always X minus H. There it is. And the K will always be next to the Y. Look at this one. The K is next to the Y, and the H is next to the X. Now, let me go back once again to the previous practice that we did. Look up. On the previous equation, it didn't have transformation, so it was going through 0, 0. But look at the focus. The focus had 0 and a number. The focus has, a number and 0, but still it has 0 somewhere in the focus. Today, we're no longer going to have zeros. Why? Because now we're going to move things around. Which means, check this out, we need to find out how to write our equation just given the information on the problem. So here we go. So I'm going to do some practice to see and to make sure that you know how to write your equation before we get started with the practice. Ready? Here it goes. I'm going to get your brain ready. So tonight, they're going to say graph. Don't copy this. This is just practice. They're going to give us a focus, and they're going to give you a directrix. Okay? Now check this out. Let's think about yesterday. If it was yesterday and I said the directrix is y equals 2. For yesterday's home plate, what equation would you write there, everyone? X squared equals 4py. That is correct. However, today they're going to give us a focus that looks something like this. No longer with a 0. Which means I cannot use this equation anymore, but I can use the one with a transformation. So look up. This is still x, right? So now that we have a transformation, what do I write here? X minus h equals 2 for p, and instead of y, what do I write? Y minus k. That's simple. What if it was x equals -3? So according to yesterday, we would have written what? Y squared equals 4px. Is that correct? But now with this focus, what would I write? Y minus k squared equals 4p and x minus. That is correct. Let's do another one, just because I sense a disturbance in the force. All right, let's see. Here it goes. Let's do x equals 7. If it was yesterday, it's telling you the equation that you would use for yesterday. Y squared equals 4px, yes? However, today, since I'm going to give you different values now, here for the focus, tell your equation now, fixing that equation with a transformation. What is that equation? All right, let's see. Go, Carlos. What you got?
Y minus 8.
Y minus k.
Squared equals 4p x minus 8.
Yes. Hands, have you got that? Okay. Okay, now that we got our brain ready, get your big graph paper in front of you. Here we go. Let's get started. Let's go. Let's go. Copy the instructions. It says, example 1, write and graph the equation of the parabola with focus 3, 2 and directrix y equals 0. Focus 3, 2, directrix y equals 0. Copy that. I'll give you some time. we're like, yeah, right, Mr. Q. Anyways, first things first, let's look at the directrix. If it was yesterday, you know what equation to use, right? But today, notice the focus doesn't have zeros anymore. So, tell your neighbor first the equation that you're going to use now. All right, this is what I want you to do. I want you to write it somewhere right here about halfway down the paper, our new equation. All right, let's see. Raymond, what is our equation now?
X minus 8 squared equals 4p times y minus 10.
Yeah, x minus 8 squared equals 4p times y minus k. Hands, have you got that? Okay, so do me a favor. With green, I want you to overlay the h and the k. Because at the end we need to use that equation to write our equation for the parabola that we're going to graph. Okay? However, to get started and get organized, on top over here, guys, I want you to write this down. With red, I want you to write F for focus, get a parentheses. Underneath that, with green, you're going to write V for vertex in green. And with blue, you're going to write D for what? Directrix point, yes. Also, I'm going to give you a little formula because we need to figure out the distance between the points known as P. How do we find that distance? We're going to take two numbers and subtract them. Divide by 2 because it's the distance between 2 points. And that's going to give us the value for P. That's just so that we can stay organized, okay? Copy that really quick. All right, here we go. So, this is going to keep us organized. Put your thinking cap on because this is where it's going to start. We need to start thinking through to make sure we understand each component. Ready? Here we go. So yesterday we said start with the focus. I'm going to do that in red. Let's plot 3, 2. 3, 2. I'm going to fill in my coordinate here, 3, 2. Next, let's graph the directrix line. What is that line? Y equals 0. 0 is right here of y, and it's a horizontal line. A horizontal line going to 0 of y. There it is. Now, I hope you notice that compared to what we did yesterday, now the point is off to one side, the focus, and the point that we plotted for our line. Is that correct? However, don't you agree to make a line, it requires an infinite amount of points? So can you picture the point aligned to the focus? Yes? Tell your neighbor that coordinate, please. What is the coordinate of that point? If you don't see it, start with the focus, go straight to the directrix, and plot a point there. And what is the coordinate there? It's 3, 0. So let's write that in here. 3, 0. All right. So looking at these 2 points, look up, or looking at these 2 coordinates, what value do they have in common? The x value, right? So what can we conclude if I was to place a point in between those? That this one will also have what in common? So let's write that in there for the vertex. Let's write 3 for x. And just to remember, our vertex now is HK, no longer 0, 0, yes? So what does that mean, Mr. Q? That we need to find K. So we're going to use some algebra. So right on the side of that, I'm going to write a little formula. To find K, we need to use the y value of the focus and then subtract the distance between the points, also known as P. Do we have P? No. How do we find them? Well, we started with this point and this point, didn't we? So that means I'm going to take the 2 values, 2 and 0, and subtract them. So I'm going to write them here, 2 and 0. So what is 2 minus 0? 2. Since it's 2 different distances, that's why we divide by 2. So what is 2 over 2? 1. Okay. Now that we have the value for P, that one's going to go here, right? This one goes here. What goes here, guys? The y value of the focus. What is the y value? 2. So let's substitute that in here. 2 minus P, which is 1. So our K is 1. Is that correct? And it goes right here. So let's plot that point, 3, 1. 3, 1. Question. Let's verify to make sure we got it right. Is the vertex the same distance from the focus than the directrix? Yes, it's the same distance, so that means our computation was correct. Now, up to right there, from 1 to 5, how comfortable are you so far? Where are we at? 4, 5, 4, 5, yes, okay. Now check this out. To graph, I don't want to add a table at this time to make it more complex. I just want you to graph me a parabola by what we have there. You're like, how do I do that, Mr. Q? Well, just graph a parabola without a table. Haven't we been practicing that on the warm-up? Yes. Where's our vertex? Here. And what did you notice on last night's home plate? All the parabolas opened. Question, did they open towards the directrix or away from the directrix? Think about it. Towards the directrix or away? Everyone? Away. So that means I'm going to graph my parabola away from the directrix. Okay. So, first part, which is graphing, we're done. What's the next part? It says to what? Write an equation. So that means I'm going to take the equation I started with, look up, x minus 4 parentheses y minus, and then substitute values and simplify. So question, where am I getting h and k from? Tell your neighbor, please. Where am I going to get h and k from? Hence the color green. Tell your neighbor, where am I getting h and k from? Yeah, the vertex, which is in green. This one is h, this one is k, so here I'm going to write 3, and over here I'm going to write 1. What's left? The value of p, which is 1. And now we just rewrite this. We got x minus 3 squared equals, what is 4 times 1? 4, y minus 1. And we leave it like this because this is our standard form equation. That's the whole thing for today. From 1 to 5, how comfortable do you feel? 4, 5, 4. Let's do another one together to make sure we get plenty of practice here. Okay? So here goes the process just to make sure we got it. What is the first thing we did? They gave us a focus and a directrix. We look at the directrix, we write our equation, our new equation. Next, to get organized, I write F with a blank coordinate V, blank coordinate D, blank coordinate, and our formula to find the distance between the points, which is P. We plot our focus, graph our directrix, and then we get started with our coordinates. Here's the focus. We plotted a point aligned to the focus. That was our directrix point. And then we saw that they're going to have in common the x, so we wrote the same value for the vertex. We used the formula here that we wrote for k, substitute values, but then we needed to find p, so we took these values here from one point to the other, subtracted, divided by 2. That's how we got that. We get k, plot it, graph our parabola, substitute values, and simplify. All right, copy this next one, please. Example 1 super cube. You don't have to copy the entire instructions, just copy focus for 5 and directrix y equals 1. You can turn your paper over. In the back you have about 4 graphs. Use one of them. Halfway down one coordinate plane, I want you to write your new equation according to the directrix. Look at the directrix. Something squared, 4p, and something. All right, share with your neighbor your equation, see if they got it. So you should have written ax minus h and y minus k. So far, so good? Yes, Mr. Q. Next, you need to get organized first before we get started. So we write F for focus, V for vertex, D for directrix point, and P for the distance between the 2 points. We're going to subtract those, divide by 2. That's how we get the value of P. All right? From there, what's the first thing we're going to do, Noor? Yeah, plot the focus. So our focus is 4, 5. 4, 5. And then we write our coordinates, 4, 5. Next, what do we do next, Brooke? Yes, plot that one. Yeah, the directrix, we graph y equals 1. Y equals 1 is right here, so it's a straight line going through there. It's a horizontal line. There it is. But we need a coordinate for the directrix point that's aligned to the focus. Tell your neighbor that point. What are the coordinates for that point? Alright, so let's see. You should have gone straight down the focus to the directrix, plotted your point, and that is what? 4, 1. 4, 1. Alright, and what do we have in common, we said? The 4, so we write it here for the vertex. Alright, so let's write our formula to find k. To find k, we need the y value of the what? Of the focus. And then we're going to subtract the distance between the points, which is p. How do we find that distance? Tell your neighbor. Look at the numbers that's given. How do we find that distance, please? Andrew, go. What am I going to do? The 5 and the 1, yes. So 5 minus 1 is 4. Divided by 2 because it's 2 distances, so the distance of each point is 2. That's going to go right third. What is the y value of the focus? The y value of the focus is 5. So my k is 3. Plot that point. Let's see if it's equidistant from the others. 4, 3. Is it equidistant from the point and of the focus in the directrix? Yes. Sketch your parabola. So you should have done something like this, away from the directrix. And if you got that, okay. So we're done with graphing. Now we need to write our equation. So what do? Parentheses x minus blank squared equals 4 times, and then parentheses y minus blank. Let's see if you can fill that in by yourself. Alright, so we need an h and we need a k. Tell your neighbor where to get h and k from. Yeah, for those of you that forgot, I'm going to write it over here again. The vertex is always hk. So if my vertex is hk, that means h is 4, k is 3. What is p? P is 2. Rewrite this. X minus 4 squared equals 8, y minus 3. And we're done. Let's go. Do this. From 1 to 5, how comfortable are you with these so far? 5 fours, 5 fours, okay. Once again, I'm not going to ask you to do a table to get more points on the parabola. I just want to make sure that we got it up to right there, okay? Let's do another one. Here it goes. Example 2Q, copy this. Focus 5, 4, directrix x equals 1. Focus 5, 4, directrix x equals 1. So halfway down the coordinate plane, tell your neighbor what equation to write here now with the directrix x equals 1. So our equation is what, Saul? Y minus k, very good. Minus h, yes. Remember, the h always goes next to the x. Remember on the general rule for transformations, it was x minus h. You guys remember that? Yeah, I'm going to change that to green again, the k and the h. All right, let's get organized. We got F for focus, V for vertex, D for directrix, P for distance between the points, divided by 2. Okay. All right, let's get started. Here we go. All right, where do we start? The focus is 5, 4. 5, 4. I'm going to write it here. Directrix is at x equals 1. X equals 1 is right here. There's a line going straight through there. That means it's a vertical line. You're like, oh, snap, Mr. Q. Yep. All right. Can we picture the point aligning the focus to the directrix? Say near the coordinate for that. It is 1, 4. What do you guys notice now we have in common? The 4. Look at that. 4, 4. That means this one has a 4. You're like, oh, snap, Mr. Q. So no longer are we looking at K. Now we need to find what? H. Now think about this. The other one we did K, and we took the Y value of the focus. This one to find H, what are we going to take? The X value of the focus. And subtract P. So to find P, I'm going to take 5 and 1. So 5 minus 1 is 4. Divided by 2 is 2. That goes here. Minus the X value of the focus is 5. H is 3. So 3, 4 is right there. Graph our parabola. And do we know how to substitute values here to write our equation? Yes, just be careful, guys. For K, goes here, it's a 4. For for H, it goes over here. And the rest is history. Good one, guys. Enjoy your home play. See you guys tomorrow. Bye.